Hello everyone, today we are going to do a Codeforces question, Tenzing n books. In this, we are given 3 stacks, each of size n, and there are n books, and each book has a particular difficulty. So currently, we are having a knowledge 0, and by reading each book, we will get a knowledge of v by using this formula. Like suppose we have initial knowledge u, then after reading a book with difficulty v, we will have a knowledge of u or v. This is OR operator. So we have to find out by reading some books, is there any possibility that we can gather a knowledge of x? So this is the input. Here we are given that each stack has 5 books, and we have to gather a knowledge of total x. So what we have to do in this, we have 3 stacks. This is top of the stack, and we have to read from here. So we have to make a total knowledge of this 7. So how we will do this? We will do this by using bit masking. So what we will do? Suppose we want to make 7. So suppose initial knowledge is u, and u is equals to 0. What we will do? We will start from here. First we will iterate through the first stack, then the second stack, and then the third stack. First we will see here that binary form of 7. So binary form of 7 is 1 and 1. So this is the binary form of 7. So what we have to do? We have to create 7 by using this u current knowledge and by using these difficulties. So if we are doing OR with u, then this should not be greater than this, which is the x. So what we'll keep in mind that whenever we do OR of the difficulty, then we will have to see that wherever there is a set bit in x, these difficulties should also have the set bits there only. First we will check that x or ARR1 of I we are checking, then this should be equal to x. What does it mean? Suppose we have x equals to this and ARR1 of 0 is 0, 0, 1. Then its OR will be 1, 1 and 1. Okay, so we will only add those books in our knowledge which are having set bits equal to x. If there are less number of set bits than x, then it's fine, but it should not be at those places where bits are not set. Suppose if x is like this 1, 1, 0, 1, and we are having a book that is having this difficulty level, and then we will not be adding this in our knowledge because if we will OR this value with our current knowledge, then it will set a bit here at this position, and by setting bit at this position, we will not be able to reset here because we are doing the OR operation. So we will use only those books which are having set bits at those positions only where x is having set bit. So we will always keep in mind that we are going to add those books in our knowledge which are having set bits at only those positions where x is having set bits. And if these values are having set bits at those positions where x is not having a set bit, we are not going to add those values in our knowledge. So initially we will take u is equals to 0 and start from here. Okay, and then we will stop where x is not having a set bit, and these values are having that set bit. For this 1, 2, 3, 4 and 5. Okay, so 1 is like 0, 0, 1, then 7 is this, then it's fine because 1 is always having set bit at those positions where x is having a set bit. Okay, let's see for 2, then we will also take 2. Let's see for 3, it is also fine. Let's see for 4, then it is also fine. Let's see for 5, it is also fine. Then we will take all these values. Then let's come to the second stack. See here also we are going to take all the values. We are going to take all the values because it follows the same rule. Now let's see the last stack. We will take this, we will take this, we will take this, we will take this, but we will not be taking this. Why? Because here this bit of x is not set, but this bit of x of this value is set. We will not be taking this value, and if anything is beyond this value, we are not going to take those values also. So we are taking till here. So what we will be doing, we will be taking u as 0, and then we will be doing OR with all these values until here. If we are getting the value of u is equals to x, then only we will be able to get x. Otherwise, we won't be able to get x. So this was the algorithm for this question. And what will be its time complexity? As we are iterating at max, we will be iterating through the whole stack. Then here it will take order of n time. Here it will take order of n time, and here also it will take order of n time. So total time complexity will be big O of n.